Hello students, in our this lecture of physics we will learn about a moving coil galvanometer. If we want to find a current or voltage, we have to use some instrument for that. Till now in our discussion we have talked about current and voltages, but how can we find that the circuit the current is 2.5 ampere or voltage through or between two ends of a resistor is 5 volt? How can we find that the voltage drop between two ends of a resistor is 5 ohm? So one can find this current and voltage with the help of an galvanometer. So this is the figure of a moving coil galvanometer. In short, we can call it MCG. So this is the diagram of moving coil galvanometer. We can see in the figure that we have two radial uniform magnetic field and as for this is our scale, this is pointer. We can find here the value of current or voltages. This is our permanent magnet, this is our coil. In there is a spring. This is our soft iron core, this is uniform magnetic field, and the field is in a radial direction. So this is the diagram of moving coil galvanometer. With the help of this galvanometer, we can find currents and voltages in the circuit. So now we learn that how this galvanometer works. So we will learn of working principle of this galvanometer. So first point consists of a coil. This galvanometer consists of a coil with many turns. There are so many turns in coils in actual galvanometer. So with many turns free to rotate, this coil is adjusted in such direction that it can freely rotate about its axis in a uniform magnetic field. This magnetic field is uniform and radial. Once again, this galvanometer consists of a coil. We can see here coil with many turns free to rotate about its fixed axis. The axis of rotating is fixed in a uniform magnetic field. Cylindrical soft iron core. We can see here, this is our cylindrical soft iron core. So what is this core? This stands for, so cylindrical soft iron core makes the field radial and increases the strength of the magnetic field. The use of this core is increasing the strength of magnetic field. We can see here cylindrical soft iron core makes the field radial and increases the strength of the magnetic field. Now when current flows through the coil, when we passes the current through this coil, the torque acts on it. The torque acts on this spring when we pass the current through that coil. So that coil will experience a torque, and the value of torque we can find from this equation. Tau equal to NIAT. Here A is the area, B is magnetic field, I is current, and N is number of turns. Since the field is radial, in this side we have taken sin theta equal to 1. We can see here the field is in the radial direction, so we have taken sin theta equal to 1. This magnetic field tends to rotate the field. This magnetic field rotates this coil in a circular path. Now spring ST provides a counter torque that balances the magnetic torque NIAB resulting in angular deflection phi. As the spring or coil, as the coil moves in one direction, this spring provides a counter torque that opposes the motion of a coil. So we can say that spring provides a counter torque that balances the magnetic torque NIT, resulting in a steady angular deflection phi. So we can compare these both values. K phi equal to NIAB. What is K? So K is torsional constant of the spring. For example, the restoring torque per unit twist. This restoring torque balances the pointer in its mid position. Now the deflection is indicated on the scale by pointer attached to the spring. We can see here our pointer. This pointer shows the value of current or voltage. So we can write here phi equal to NAB upon K into I. The terms which are in the brackets are constant for this given galvanometer. So we can write that phi is directly proportional to I. So the current is directly proportional to the deflection of pointer or a coil. So this is the working principle of this moving coil galvanometer. In our next video lecture we will learn that how can we make this galvanometer as to measure the current or voltage. If we want to measure the current and voltages with this galvanometer, so we have to put some differences in this galvanometer, but we will learn this both topics in our next lecture. Thank you.